Hello everybody, Mr. Wallace here with another video. Today we're going to be learning about parallel lines and transversal lines. So just to get some vocabulary out of the way, parallel lines are lines that never intersect. Since they have the same slope, they're always traveling the same distance apart and they will never meet. A transversal is a line that crosses parallel lines. Trans means between, so a transversal line just cuts between two parallel lines. And we're going to be studying transversal lines today and how they create different pairs of congruent and supplementary angles. You should know by now that congruent means equal or identical or exact replicas of one another. Congruent angles should be equal in measure. And supplementary from last lecture means angles that add up to 180 degrees. So here's a picture of what I mean. Parallel lines, line M and line N are parallel, and the transversal cuts in between the two and goes through it. So I just want to go over some vocabulary and how we can tell that two lines are parallel. So there are several ways in geometry that we can note that lines are parallel. The first one is by just marking the parallel lines with arrows. So if you ever see a picture with these markings on it, it means the two lines are parallel. We can also make a little sentence from it. So this is line AB. So that's line AB is parallel to line CD. These two vertical lines just mean parallel. So that's a symbol that means parallel. And these are symbols that mark a drawing to show that two lines are parallel. Here's our transversal line. Believe it or not, if we know one angle that's made by the transversal, we can figure out all of the other angles that the transversal has made. So let's talk about this interesting relationship. So first of all, I see two supplementary angles. So the missing part that helps it add up to 180 is going to be 50. So that line's 50, that angle's 50 degrees. Covering this up, I also see that this is a pair of supplementary angles. So this angle is also 50 degrees. And I can also do the opposite. I can cover up this side and look. These two angles should be supplementary to one another. So the missing part here is going to be 130 to help it add up to 180. So we're halfway there. Next, this angle is congruent to this angle because they are both being cut by the same line. This line has a certain slope, and since these lines are parallel, they're making the exact same image, same angle measure. So this is just 130. And then I would repeat the steps of knowing about supplementary angles to fill in the rest of this. So these two are supplementary, 50 degrees. 130, and this one are supplementary, another 50 degrees, and then covering that up, these two angles are supplementary, so another 130 degrees. And that's all it takes. That's all the logic behind it to show that there's only two different angle measures when we have a transversal line. So now we need to go over how these are related to one another. And here's a lot of vocabulary you need to take down in your notes. First, we have corresponding angles. Corresponding angles are on the same side of the transversal as well as in relation to the parallel lines in the same position. So for instance, this is all color coded here to show the pairs of corresponding angles. Angle 1 is to the left of the transversal and above the parallel line. Angle 5 is also to the left of the transversal and above this parallel line. So they're both to the left and above, so they are congruent to one another. Same thing we could say about this one. It's above the parallel line and to the right of the transversal. This one is above the parallel line and to the right of the transversal. And then you can see the dark blue pairs and light blue pairs are also. This one happens to be below and to the left, and that one's below and to the left. I think you get the idea. Next, we have alternate interior angles. Alternate means they are on opposite sides of the transversal, and interior means inside. So they are inside of both of those parallel lines. For instance, with these purple ones, this one is to the right of the transversal and inside of the pair of parallel lines. This one's to the left and inside both the parallel lines. The relationship between alternate interior angles is that they are congruent to one another. They have the same angle measure. Moving on, we have same side interior angles. So they are on the same side of the transversal line, and they are inside of the pair of parallel lines. These angles are not congruent, but they are supplementary. So they'll both add up to 180. Same with these light blue ones. Next, we have alternate exterior angles. So exterior means on the outside. Alternate means they are on opposite sides of the transversal. So our light blue, number 1 is above, or it's outside of the pair of parallel lines, and it's to the left of the transversal. This one's to the right of the transversal and on the outside of the parallel lines. These two angles are related because they are congruent. Same side exterior angles are on the same side and on the outside of the pair of parallel lines. Can't be more clear than that. These angles are not congruent, however, they are supplementary. Adding both of these angles up should get you 180 degrees. And lastly, we have vertical angles. Vertical angles are across from one another when you pass through the vertex of an angle. So that point where two lines intersect to make an angle, if you cross through that diagonally, you'll see two angles that happen to be congruent to one another. So all of these pairs are congruent to one another. And this is going to be very helpful Overall, it's a simple concept to understand once you get the vocabulary down. So I'd like you all to take a minute to pause this video and identify with a vocabulary word the type of angle pairs, whether they're alternate interior, alternate exterior, etc. Okay, let's take a look at the answers. We have corresponding angles here. This one is to the left of the transversal and above the transversal, above the parallel. This one's to the left of the transversal and above the parallel, corresponding. Next, we have same side exterior. They are not congruent to one another, but they are supplementary. Here's our parallel lines. They are on the outside of them, but they are both above the transversal. Same side exterior. Alternate interior, because they are on opposite sides of the transversal and on the inside of the parallel lines. Alternate exterior, opposite sides of the transversal and outside of the parallels. This one's the same side interior. They are both inside that set of parallel lines, and they are above the transversal. And lastly, we have vertical angles. They are diagonal from one another as you pass through the vertex. Okay, so now let's actually do some math with angles. If I give you this one, this is angle 1. If angle 1 is 125 degrees, you should be able to figure out all the missing parts using those relationships between vertical angles, corresponding angles, etc. So take a minute to pause and figure out all the missing parts. Okay, let's take a look at the answers. Check your answers to see if you're right. As you can see, there's only two different types of angles here. You can use the fact that we have supplementary angles and we have vertical angles are congruent. All those facts help you fill in the blanks. Now, what if we used algebra? If I have algebraic expressions, could I find the actual angle measures? We have this angle being given away and this angle equal to something. How are these two related? Well, both of these are vertical angles, and vertical angles are congruent to one another. So I can set this term equal to this expression. So 6x equals 5x plus 10. And now we just have to do some algebra to solve. We need to get the x's on both sides, so I'm going to subtract x from each side. X equals 10. And now that I know that x equals 10, I'm going to substitute that number back in for x. So I see that this angle measure is 60, and this angle measure is also 60. Knowing that these two are 60, we can figure out all the other missing parts. These two are supplementary, so that one's 120. That one is 120 as well. And then using the facts of corresponding angles can help me fill in the rest of those. Okay, one more. Looking at the relationship between these two angles right here, they are on the same side of the transversal, and they are inside the set of parallel lines. These are same side interior angles, and same side interior angles are supplementary to one another. So I'm going to take this angle, this expression, plus this expression should add up to 180. So now I have my algebraic equation set up. we are going to combine like terms. So 20x plus 24x adds up to 44x. A positive 5 plus a negative 1. Subtract away 1, positive 4. And now we have 44x plus 4 is 180. This is just a two-step problem that you should have learned how to solve in Math 1. So we're going to move the constant over first. Subtract 4 from each side. 44x is 176. And then we need to divide by the coefficient. Divide each side by 44, and x is 4. Now that I know that x is 4, I'm going to substitute that number back in place of x. 20 times 4 is 80. 80 plus 5 is 85. So we have 85 here. 4 times 24, that's 80 plus 16, that is 96. 96 minus 1 is 95. So now we can use the fact of supplementary angles as well as vertical angles to fill in the blanks of all these other missing parts. So the main thing you need to study in this lesson are the different vocabulary words that describe the relationships, whether they're same side interior, vertical angles, corresponding angles. That's what you need to know. All right, thank you for your time, and I'll see you later.